Hey everyone, we're finally going to look at how do we graph sine functions. Right? We looked at the basic graph of y equals sine x or y equals cosine x, but what if I had a function of the form y equals a sine b times x minus c, or y equals a cosine b times x minus c? Now if you remember, the graphs of sine and cosine really have no difference in shape, right? The only thing that's different is their starting point, in a sense. And as I said, if you just go ahead and shift your graph, a sine graph a little to the left, you're going to end up with a cosine graph, okay? So the procedure for graphing sine and cosine really remains the same. All right, so let's look at how do we graph this particular function here, which is y equals 3 sine 2 times x minus pi over 4. Okay, so if I just do a direct comparison here, okay, so the first thing that I want to do here, remember what I said was, I said that when we're graphing, the things that we're interested in are the amplitude, the phase shift, and the period. Okay, so we need to figure those out. So how do we figure those out? So I want to first find out, like I said, the amplitude, period, and phase shift. Okay, so we have y equals 3 sine 2 times x minus pi over 4. If I just compare it here, I see that a is equal to 3, b is equal to 2, and then c equals pi over 4. Okay, so my amplitude is given by absolute value of a, which is 3 in this case, right? Now we know that the period of a sine function is going to be 2 pi. But if you remember from our section on transformations, if I multiply anything in here, right, in the inside of sine to my x, what's going to happen? This is going to cause a horizontal compression, right, towards the y-axis. So my graph, instead of being, say, something like that, right, it's going to be a little bit more compressed, like something like that. Okay, so we're going to figure out how much that compression is. So if there's a compression, obviously the period of my function changes. So how do I give the period of my function? Well, my period is given by 2 pi, which, by the way, is your period of the sine function, and you divide that by b, right? So if b is greater than 1, then what's going to happen? Well, that's going to give me a smaller one. If b is greater than 1, then this one is going to be less than 2 pi, and so that's going to give me a compression. If b was, let's say, 1/2, then this one would become 4 pi, in which that would become a stretch in the horizontal direction, right? So for us, 2 pi over b is 2 pi over 2, which is just pi. So if you see that from 2 pi, my period now is pi here, which means the sine function has been compressed to half its size, right? And then we have my amplitude or phase shift. And as you can see here, what is my phase shift? Well, my phase shift is given by c, which in this case is pi over 4, right? And again, if I'm subtracting pi over 4, which means my function is going to move to the right. And so this is, since c is greater than 0, it's pi over 4. It's the horizontal shift to the right by pi over 4. Okay, so my first step is always figuring out what are the important details, which is the amplitude, period, and phase shift. All right, now in my step number 2, what I want to do in step number 2 is basically I want to go ahead and compute the one cycle, right? So compute the interval for one cycle. Okay, or basically what I want to do is I want to get that one period interval. And how is this given? Well, now think about your sine function, right? What's happened is the sine function has shifted from by pi over 4 to the left, right, or to the right. So if you look at my one period, right, this is 0 to 2 pi. Now this one has shifted, think about it this way, right, by pi over 4. So now my starting point is not 0 for this one cycle, it's actually pi over 4. So in this case, my one period is given by c comma, c plus 2 pi over b. Okay, so this is the new one period cycle. Okay, and this is given by, for us, what is c? Well, c was given by pi over 4. And our 2 pi over b, which is the period, is given by pi. Sorry, this should be pi over 4 plus pi. So basically, it is pi over 4. And if you add these up, right, multiply this by 4 over 4, and I'm going to get 5 pi over 4. Okay? So this is where I will get my one complete cycle for my sine function. Okay? So that's my one period of this sine function over here. Now, if you think about your sine function, right, I'm just going to quickly draw this sine function out here again. Right? I can divide the sine function into 4 parts, right? This is one over here, and then one over here. So I have 4 parts. In a sense, this is 1, 2, 3, and 4. Okay? So I can identify, these are my endpoints, and then I can identify 3 other points. Right? So this is where I'm going to have the max, this is where I'm going to have the min. Now, if you know about anything about the symmetry of the sine function, we know that, right, this point here where I get the maximum is going to be right in the middle of this, right? So that's going to be 1/4 distance of your period, and this is going to be 3/4 distance of your period, right? And then this point here is smack in the middle of that one period. So what I want to do in my next step here is step 3 is divide this interval c comma c plus 2 pi over b into equal parts, or 4 equal parts rather. Okay, and each of those parts will be of length, right? It has to be length 1/4. If this is my entire period, well, this has to be 1/4 of my period, and so of length 1/4 of 2 pi over b. So for us, for this function, 2 pi, what was 2 pi over b? 2 pi over b was our period, which was pi. So this is pi over 4. Okay, so how do I get those points now, right? Each of these length has to be pi over 4. How do I do that? Well, I start with my point here. I have pi over 4. Okay, what I do now is I go ahead and add this to my starting point. So I have pi over 4 plus pi over 4, which gives me pi over 2, right? So that's 1. Okay, so that's going to be this point over here. Then I'm going to take this point that I just got, which is pi over 2, and add another pi over 4. Okay, and that's going to give me 3 pi over 4. Okay, and for us, that's going to be this part here. Then I'm going to go ahead and take this one here, which is 3 pi over 4, and add another pi over 4. Okay, and that's going to give me pi. Okay, and then finally, I'm going to take this pi and add a pi over 4, and that's going to give me 5 pi over 4. So if you do this correct, and if you start from here and start adding this quantity 1/4 the period, you're going to end up at this point. So if you don't, you've probably made some addition error over here. Okay, so these are my key points, right? These are our 2 endpoints, right? Pi over 4 and 5 pi over 4 are the endpoints of my interval, and then I have divided that in 4 parts. So I get these 3 key points, that is pi over 2, 3 pi over 4, and pi. Okay, so take a look at this for a minute. Okay, so now that we have all our information, let's go ahead and graph this function. So our final step here, step 5, is going to be to sketch the graph. Okay, so I'm going to go ahead Remember, I only want to sketch one cycle. Okay, and what did we see? Our starting point here was pi over 4, right? So I'm going to go ahead and mark pi over 4. And then we had 5 pi over 4, and so then divided that into 4 equal parts, I get 5 over 2. I have 3 pi over 4, pi, and then 5 pi over 4, right? Now my amplitude was 3 for this function, so this is 1, 2, and 3. So obviously it goes down to -3, -1, -2, -3. Okay, so this was the starting point. Remember, our graph of sine function normally is this. This is what my sine function looks like. Sorry, sine function normally looks like this. It goes there. What is our sine function going to look like? Well, our sine function is going to look something like that. So first of all, I'm going to start not at 0, but I'm going to start at pi over 4. At this point, I'm going to have 3. And you can verify that by plugging in pi over 2 in your equation. And then at 3 pi over 4, I'm going to have 0. At pi, I'm going to have -3. So that's going to be somewhere around here. And then I'm going to have 0 again. So in this case, my one cycle is going to look like that. Okay, so that's one cycle of my function y equals 3 sine 2x minus pi over 4. Okay, and let's go ahead and take a look at the exact graph on Desmos. All right, so let's look here in Desmos. This is our graph, y equals 3 sine 2 times x minus 4. And here's the graph we did on the board. Now, here's the same function typed in here on Desmos. So let's go ahead and take a look at that function, right? So here's my function, and I'm going to go ahead and zoom in here. Now, this point here should be pi over 4, right? This point here would be pi over 2. This point here would be 3 pi over 4, as you can see, right? So this is pi over 4, pi over 2, 3 pi over 4, pi, and 5 pi over 4. And so that gives us, right, that here gives us one complete cycle of my sine function. Now, as I've shown previously, if you look at your graph of y equals sine x, that's what that function is. So we can see that my one cycle here goes from 0 until 2 pi. Okay, so first of all, we can see that there is definitely a compression here, and also this point, which was 0, 0, is now moved on here, right? And so there's a shift, and then there's a compression and a vertical stretch.